So once you've identified what the actual yield and theoretical yield are, you put them in the wee calculation here, which is on top of the next page. So your percentage yield will be calculated by dividing your actual yield by your theoretical yield, times it by 100, make it in the percentage. A wee analogy to think about, if you were to calculate the percentage you got on the test, if you think about the theoretical mark you should have got on the test was 100%, or full marks, the actual yield was what you actually got on the test. So you divide the mark you got by the mark, that's the maximum mark, times by 100. Same kind of idea for working out percentage yield. What you actually got divided by what you should have got times by 100. So it's going to be easiest if I just dive straight into the question and show you how it would come up kind of in the exam. So I'm going to look through the couple of, just two of them, there's quite a few in your booklet. So the question at the bottom of page 10 here. So showing what the question looks like first, gives you an equation, ammonia reacting with nitrogen reacting with hydrogen to make ammonia. The first part of it will normally be a normal mole question, like a reacting mass question, where they give you a mass of one of the reactants, in this case hydrogen, and you have to work out the mass of a product, in this case ammonia. What makes this question different about percentage yield? It's split onto the next page. It's on page 11, you see part B. Once you've got your calculation for how much ammonia you should have got, theoretically, it'll give you in part B the actual yield of ammonia. So it tells you here that 20.3 grams of ammonia was actually formed in this reaction. With that number, calculate percentage yield. So I'll run you through both parts here. Part A is, again, hopefully familiar by now. It's a standard reacting mass question. And again, a lot of people prefer the table method, so I'll do it here. So write out your equation. 3 hydrogens and a nitrogen makes 2 NH3s, which are ammonia. Normal headings here, ratio, mass, RFM, moles. Just fill in my ratio first. 3 hydrogens react with 1 nitrogen to make 2 ammonias. In terms of what mass defined, I've got the mass of hydrogen, I'll fill it in as 12 grams, and I'm asked for the mass of ammonia, which is this bit here. So in this particular example, I don't need to worry about the nitrogen column, I can strike it out. So my general method again, I've got my mass of one of the reactants, I want to convert it into moles first. That involves using moles equals mass divided by RFM. RFM, I use my formula here, have to be really careful with things like hydrogen. Big 3 is just for balancing, it's not part of the formula. The wee 2 is part of the formula because there's 2 hydrogens joined together. So the RFM will be 1 plus 1 for 2 hydrogens, which is 2. Therefore my moles becomes mass over RFM, 12 divided by 2 is 6 moles. Need to use my ratio to work out how many moles of my ammonia I'm going to make. It's not the most straightforward one, it's a 3:2 ratio. A couple of ways I could do this. I could divide by 3 times by 2 to get that way. Or if I look at the fact that I get from 3 to 6 if I double it, so 2 to my mystery number is doubling that as well. A 3:2 ratio is the same as a 6:4 ratio, it's just twice as big. So we've got 4 moles of NH3. Need to turn back into mass, so I'm going to need to use the RFM because mass equals moles times RFM. RFM of NH3 is 14 plus 3 ones for 3 hydrogens, which is 17. Final answer becomes 17 times 4, which is 68 grams. So that's like a standard reacting mass question. The bit that makes it different is this part B. So it tells me at the end of that, I actually get 20.3 grams of ammonia. So again, and then have to calculate the percentage yield. Again, as a wee kind of exam tip, I should find that my actual yield should be less than my theoretical yield. The question says I actually got 20.3 grams of NH3. Here, clearly I've got more than, I should have got more than that, 68 grams. So percentage yield equals actual yield over theoretical yield times by 100. So the actual yield I actually got in a real life experiment, it told me in part B, was 20.3 grams. What I should have got according to my calculation was more than that. I should have got 68 grams. Times that by 100 to get a percentage, and that ends up the nearest whole number being 30%. Okay. Little exam tip as well. I could obviously, if I wasn't being careful, get this the wrong way around. My final answer should be less than 100%. Remember, you expect to get less than you should have got. Your reaction is never perfect. So, I'm going to do one more example just to hopefully it'll make it completely solid in your head. Going to look at example 2 here. Iron is made by reduction of iron oxide with carbon monoxide. So you've got all these parts of the equation here. Part A, calculate the mass of iron that can be formed from 126 grams of iron oxide, and then it gives you in part B an actual yield, 78.5 grams, turn that into percentage yield. So the first part down here, so I've got my equation, Fe2O3 plus 3CO goes to 2Fe plus 3CO2. Will it give me the question? It gives me that I've got 126 grams of iron oxide. This is iron oxide here. So I probably should have filled in my ratio first. 1 iron oxide, 3 carbon monoxides, 2 irons and 3 carbon dioxides. What's it asking me to find? It wants me to calculate the mass of iron. So it's this column here I need to be worried about. That means the carbon monoxide column is not important. The carbon dioxide column is not important. So RFM here, need to work that out for the moles first. RFM of iron oxide is 56 plus 56 plus 3/16, which is 160. The moles, therefore, using moles equals mass divided by RFM, 126 over 160 gives me a number of moles of 0.79. Need to use my ratio here to get the mass of iron I expect to get. It's a 1 to 2 ratio, therefore 0.79 I need to times by 2. According to that ratio, gives me 1.58 moles of iron. Back into mass, need to times it by the RFM because mass equals moles times RFM. RFM of iron here, remember, ignore big 2, it's just for balancing, not part of the formula. It's just an Fe by itself. Periodic table, mass number tells me it's 56 for iron. Therefore, my mass becomes 1.58 times by 56, which is 88.2 grams. So first part of the question done, and that would be the majority of the marks. Little 2 marker at the end, probably an exam. It tells me 78.5 grams was formed in the reaction, calculate percentage yield. Again, my wee logical check, that's what I actually got, and it's 78.5, which is less than what I should have got in theory, 88.2, which makes sense to me. So my calculation finished off, percentage yield equals actual yield over theoretical yield times by 100. Actual yield, I got in the actual experiment 78.5 grams. What I should have got was 88.2 grams. Times it by 100 to make it in the percentage, and that will give me a final answer of, to the whole nearest whole number, 89%. So there are 2 further examples on this page 11. I'm not going to do the working out just because I don't want to make this video too long, but I will just give you the numerical answers to them if you want to have a go at them yourself. So this 3 part A talks about chlorine being made from sodium chloride. Part A, calculate the mass of chlorine made from 50 grams sodium chloride. If you do your mole calculation, your final answer should come out as being 30.3 grams of chlorine in that reaction. Taking into account your 25 grams, which is your actual yield versus your theoretical yield, should come out as 83% for your percentage yield for that question. Question 4, maybe slightly trickier, it's in kilograms. Remember, I have to convert that into grams first, 1250 grams for chromium oxide. If you're trying to work out the amount of chromium you make from that amount of chromium oxide, using your table method, it should come out as 855 grams. Using 756 as your actual yield versus that theoretical yield, your percentage yields should come out as being 88%.